Alright, in this problem we have a guy throwing a ball, hitting another guy hitting with a bat, gives us the mass, and tells us that the bat and ball are in contact for 0.07 seconds. What we're looking for here is the change in momentum. Here I have change in momentum. I could do force times time, but I don't have the force. I could do m times change in v. So I have the mass, I have the velocity initial, and I have the velocity final. Okay, so let's go to work. Change in momentum, change in momentum equals the mass, which is 0.2 kilograms, times our change in velocity. Change in velocity is v final minus v initial. So v final is 20 minus v initial is 8. Okay? Now if you did this, it would actually be incorrect, because what's the biggest thing we need to worry about? Is momentum a vector or a scalar? Hopefully you entered vector. Alright, so this would have to be, since this one is going to the left, I would make this negative 20. Then I would do that. So my change in momentum is 0.2 times negative 28, and I end up with a change in momentum of negative 5.6. Does that make sense? Well, if I start out with positive momentum and I end up with negative momentum, I have lost momentum. Also, it is going the opposite way, but here I have lost momentum. Kind of like your bank account, if you go from $5 to negative $20, you've lost a lot of money. The next question here says, what is the J? Right? So right here, what's the J, which is J net? Right? And hopefully, if you know all the equations, you write them down, you would quickly see that right here, J net equals change in momentum. So that is also the same answer, negative 2.56. Right? The last part, what is the F average? Right? So if I looked at this one, my F average, well, that is multiplied by time equals change in P or J. They're both the same thing, doesn't matter. So plug in my numbers, I'm looking for force average. Then I know the time it gave me right here, 0.07 seconds, equals the change in momentum, which is the negative 5.6 kilograms times meters per second, divide by 0.07, divide by 0.07, and I ended up with, on this one, divided by 0.07, a negative 80. So the force average equals negative 80 newtons. Always need to go back and check, does it make sense? From the picture up here, I can see, that the force, this is on the ball, okay? The force on the ball is this direction. And we know that force should be a negative. Okay? What would the force be on the bat? If the force on the ball by the bat is negative 80, the force of the ball on the bat should also be negative 80. On the next problem, let's do a follow-up. It says if the bat will break if more than 50 newtons is applied to it, what is the maximum speed that the ball can be hit? Again, assume the time is 0.07 seconds. If we looked back, we can see here that we had a force of negative 80 down here at the bottom. Right? So it would have broken with that speed that this guy threw it with. So now I got to go back and try and figure out what the force, the speed that they can hit the ball, so not thrown, still the same. So start with my equation. I'm looking for force, so I need F times T. It can be average or a constant, either one is fine. Equals, what information do I have? Well, I have mass and delta V, because I need the velocity. So this is limited to 50 as our force. My time is still 0.07 seconds equals the mass. What do we say the mass was in this last problem? 0.2. So that's 0.2 kilograms, that's our right unit, and then times my final velocity minus the initial velocity, and we said that was 8. Doing my algebra here, I would do 50 times 0.07, and I get 3.5, divide that by 0.2, and I get 17.5 equals V final minus V initial. Or, excuse me, V final minus V. Now if I notice I do this problem, I'm going to get 17 plus 8. Right? Well, the velocity last time, in the previous problem, let me just go back here, was 20. Right? So that velocity broke the bat. So this velocity would be greater than that number, so that can't be right. So what is the mistake I made? Right? Did I pay attention to direction with everything? Over here, I don't have to put negative because I'm going to solve for that. This answer should be negative. Mass cannot be negative. Time cannot be negative. Uh-oh, must be the force has to be negative. So that's going to be a negative. This is a negative. Now I add 8 to both sides, and I end up with 9.5. Excuse me, negative 9.5. Again, the direction I hit it was to the left, so that's why I have the negative. That is a less velocity I hit it back with, so that is the correct answer there.